Okay, continue with kinematics and keeping physics simple and focusing on the equations. The next one is acceleration. Acceleration is another vector quantity. So that is why there is, again, the arrow over the top to remind us that vector quantities have a direction in addition to the units. This makes sense when we look at the actual equation, which is final velocity minus initial velocity divided by the time it takes to change. Now, this is a whole lot to write down just to solve a math problem in physics. So we can simplify this by doing it this way, where we have acceleration, again with the arrow over the top, equals VF for final minus VI for initial, again the arrow over the top minus the directions, divided by this right here is the Greek letter delta. It is a triangle as well, but it is also the Greek letter delta. That's going to stand for change in time, T for time. Now the units for acceleration are going to be in terms of distance over time, which makes sense if you have, look at this equation, or it will be a little bit simpler as distance over time squared. For example, meters per second squared, or we could write that as meters per second per second. I know I kind of got these flip-flopped here according to what's over here. Now, directions. Again, the directions are going to be like up, down, compass directions, or that tricky positive, negative direction. One thing you do need to keep in mind with acceleration and the direction is that if something is decelerating, what we call decelerating everyday life, the acceleration is opposite to velocity. So if you have something that is moving in this direction for velocity, and it's starting to slow down, I'll make a note up here so you know where I'm at. It's starting to slow down. The acceleration is going to be in the opposite direction. So this could be up, this could be down, this could be northeast, this could be southwest. Just as long as you understand that if something is slowing down, it's decelerating, and velocity and acceleration are going to be in the opposite directions. So acceleration, where you're speeding up, velocity and acceleration are going to be in the same direction. Whatever is given to you, up, down, northeast, southwest, it doesn't matter. This is just a representation, an example to clarify that with direction, if something's slowing down, you need to make sure it's the opposite direction. If it's speeding up, it's going to be in the same direction. Now, trick question. If something has constant velocity, does it have acceleration? The answer is no, because this up here would equal 0, being the same numbers, and there would be no point in dividing by time, because 0 divided by whatever number this would be is going to either be an error or 0 in the calculator. So that is acceleration. The units, making sure you keep this kind of straight, maybe take a little bit of practice, and then next video or next time we'll be doing momentum.